In this entire video, we'll be seeing the introduction to networks.
Normally, the term telecommunication means a communication at a distance. The word data refers to the information presented in whatever form is agreed upon the parties creating and using the data. Data communications are the exchange of data between two devices via some form of transmission medium such as wire cable. We can see that the sender is sending a message through a medium. This mediums are connected. If the mediums are connected together, it forms a network. So, in order to send the message effectively, we need a sender, we need a medium, and we need a receiver. Apart from this, we need a protocol, that means a set of rules which is to be followed both by the sender as well as the receiver. This picture shows that there are three types of data flows available. One is simplex, half duplex, and full duplex. Simplex, the message is sent from the mainframe system or a networking system directly to the monitor. Second one is half duplex, where the message is sent between two stations but not simultaneously. That means station A will be sending a message to station B. After receiving that particular message, that station 2 will be sending a message as a reply to station 1. Next, third type is full duplex, where station A as well as station B or station 1 as well as station 2 can able to send message simultaneously. So we can say our normal telephone conversation comes under this full duplex. A network is a set of devices which is often called as nodes connected by a communication links. A node can be a computer, printer, or a desktop, laptop, workstation, cell phone, or a security system, or any other devices capable of sending and or receiving data generated by other nodes onto the network. A link can be a cable, air, optical fiber, or any medium which can transport a signal carrying information. Any network can be measured in terms of its performance, reliability, and security. These three are the very important factors to measure a network. For example, if we take our mobile service provider's network, we can measure its performance by download speed and upload speed, and its reliability, how far we are having the good signal strength, and how far they are providing us the security. Similarly, the performance can be measured in many ways, including transit time and response time. Transit time is the amount of time required for a message to travel from one device to another. Response time is the elapsed time between the inquiry and a response. The performance of a network depends on the number of factors, including the number of users, the types of transmission medium, the capabilities of the connected hardware, and the efficiency of the software. And it is normally evaluated in two networking metrics as throughput and delay. Second criteria is reliability. Failure, that means reliability is a failure rate of a network component. It is measured in terms of its availability and robustness. The third important network criteria is security. Network security issues including protecting data from unauthorized access, protecting data from damage and development, and implementing policies and procedures for recovery from breaches and data losses. Before proceeding with the types of networks, here we are seeing the physical structures of a network. For communication to occur, two devices must be connected in some way to the same link at the same time. There are two possible types of connections which is shown here. One is point to point and the next one is multi-point. In point to point network, there will be a station 1 and station 2 which is connected via the same link. Whereas in multi-point connection, there will be one server and there may be many number of stations which are tapped in the same connection links. Here we are seeing about topology. The term physical topology refers to the way in which a network is laid out physically. Two or more devices connected to a same link or two or more links to form a topology. The topology of a network is a geometric representation of the relationship of all the links and linking devices. There are four basic topologies possible. One is mesh, star, bus, and ring. To make it more clear, in our laboratory, we will be having one router to which all the remaining systems are connected via the LAN cable. So this forms a topology. The diagram which is shown here tells us about the star topology. In a star topology, each device has a dedicated point-to-point link only to a central controller. Usually, this central controller is called as a hub. These devices are not directly linked to one another, whereas each and every station is connected to the central hub. A hub is a physical layer networking device which is used to connect multiple devices in a network. They are generally used to connect computers in a LAN. Working of bus topology is shown here. Each and every stations are tapped from the central line or the central link which is connected, and they form a network. Here we are seeing the ring topology. In a ring topology, each device has a dedicated point-to-point connection with only the two devices on either side of it. A signal is passed along the ring in one direction from device to device until it reaches its destination. Each device in the ring incorporates a repeater. Repeater is nothing but a device which will boost up the signal whatever it is receiving to the next nodes. The last topology is hybrid topology. It is a combination of star as well as bus topology. Here we can see that bus 1, bus 2 and bus 3 are connected via hub. If a person or a station from bus 1 wants to send a data, the data will receive the hub and then it will be redirected to the recipient.
Fine, we have come to the end of this topic. We will see the next topic in the next video. Thank you.